This video we are going to see a representation of partial order relation using an Hasse diagram. So we all know partial order relation is also called as an poset. Partial order relation is also called as an poset. So partial order relation is a relation which satisfies the three properties of binary relation, that is reflexivity, antisymmetry, and the transitivity. So how we can represent this partial order relation using an Hasse diagram. So step 1, to draw the Hasse diagram for an poset is always represent Hasse diagram in upward direction. Upward direction. So this is first step to draw an Hasse diagram. Step 2 says in Hasse diagram we should remove the self loops and we should omit or avoid the transitivity. We should remove the self loops and we should also omit the transitivity. Self loop meaning is if we have the relation pair like 1 1 2 2, right, we can represent these relation pairs in graphical form like this. If 1 is the element, then 1 is related to 1 like this. If 2 is the element, 2 is related to 2 like this. And second is we should remove also omit remove or omit the transitivity. Okay, so we'll try to understand this by an example. Suppose we have an set A which contains 4 elements 1 2 3 4, and relation R is defined as A related to B if A divides B. A divides B is your relation, and this relation is, let us say, defined from set A to set A. So I can write relation R as every element divides itself. So I can write the pairs 1 comma 1 2 comma 2 3 comma 3 4 comma 4. Again 1 divides every element, so 1 comma 2 I can write, 1 comma 3 I can write, 1 comma 4 I can write. Then 2 divides whom? 2 divides 4. So any more pair possible? No. So this is my relation R. Now, as per definition of Hasse diagram, it is used to represent your partial order relation or poset. Meaning is this relation R can be represented in Hasse diagram. How? So we will follow the steps. So what is the first step? Always Hasse diagram is drawn in upward direction. Upward direction. Okay. So we should start from, let us say, first element in the set 1, and it is there in the relation pair also. So I can take 1 somewhere here, 1. Okay. Now in second step it is also said like we should remove the self loops in the Hasse diagram. So which are the pairs in the relation which forms the self loops? 1 comma 1 2 comma 2 3 comma 3 and 4 comma 4. So these pairs will not come in Hasse diagram as we should remove the self loops. So these pairs we should not consider in Hasse diagram. Okay, the next pair to consider in Hasse diagram is 1 comma 2. So I have taken 1 here, 2 I need to take somewhere. Let us say here I will take 2, right? And I need to represent this relation. 1 is related to 2. So, and step 1 says Hasse diagram always drawn in upward direction. So 1 is related to 2. I can show in upward direction like this. Okay. So it's not necessary 2 you should take on right hand side only. You can take on left hand side also, no problem. Okay. So at the end only it should look like a good structure. Right. So next pair to consider is 1 comma 3. Okay. So 1 is related to 3. So I taken 2 here. So let us say I'll take 3 somewhere here. So 1 is related to 3. I can represent like this. Okay. Then next pair is 1 is related to 4. So time being I'll not consider this pair. Why I'll tell you. Okay. Next pair is 2 is related to 4. So 4 I need to take somewhere. Let us say here I'll take 4. Okay, and I need to represent this relation. 2 is related to 4. So 2 is related to 4 as 2 divides 4. So 2 is related to 4. So I drawn in upward direction only. So this pair is over, this pair is over, this pair is also over. Now which pair is left? 1 comma 4. 1 comma 4. So 1 is related to 2, 2 is related to 4, it means 1 is related to 4. So this form the transitivity. And in the step 2 it is said we should omit the transitivity. So no need to draw arc like structure which shows 1 is related to 4. Right? Now let us take one more example. Suppose you have set A as 1, 2, 3, 6, 12, 24 and relation R is defined as same. A divides B. A divides B. So what are the relation pairs? Every element divides itself. So we have pairs 1, 1, 2, 2, 3, 3, 6, 6, 12, 12 and 24 comma 24. Next 1 divides all. So I can have 1, 2, 1, 3, 1, 6, 1, 12, 1, 24. Then 2 divides whom? Taken element by element. So 2 divides 6, 2 divides 12, 2 divides 24. Then take element 3. 3 divides 6, 3 divides 12, 3 divides 24. Then 6 divides 12, 6 divides 24. And last 12 divides 24. So these are the pairs I can have in my relation R. Now I had to represent this in Hasse diagram. Okay. So Hasse diagram, step 1 says always draw in upward direction. That is fine. The second step says, which is very much important, we should remove the self loops 1 comma 1, 2 comma 2, 3 comma 3, 6 comma 6, 12 comma 12, 24 comma 24. These are the pairs which forms the self loops. So I should not consider these pairs. Okay. And omit the transitivity. So whenever transitivity comes, we can neglect those pairs in the Hasse diagram. Means the transitivity arc can be ignored in Hasse diagram. So take the first pair 1 comma 2. So I can take 1 here somewhere, 1 here, then 1 divides 2. So let us say 2 I'll take somewhere here, 2. This pair is over. Then 1 divides 3. So 3 here. So 1 divides 3 upward direction, right? then 1 divides 6 is the pair, right? This automatically will come in transitivity. How? That will come in the further steps. Okay, 1 comma 12, 1 comma 24, these all will come in transitivity. Okay, then next pair is 2 comma 6, let us say 2 comma 6. So 2 is here, right? 2 divides 6, and we know 3 is also divides 6. So somewhere center I can take 6, and 2 also divides 6, 3 also divides 6. So this pair is over, 2 comma 6 and 3 comma 6. This pair is also over. Okay, right. Then 6, let next consider 6 divides whom? 6 divides 12 and 12 divides 24, right? So 6 divides 12 and 12 divides 24. So these pairs, 6 divides 12 and 12 divides 24, right? Now what about remaining pairs? These all remaining pairs have come in transitivity. See, 1 comma 6, this pair 1 comma 6. Okay, 1 divides 3, 3 divides 6 means 1 divides 6 transitivity. Then 1 comma 12, 1 divides 3, 3 divides 6, 6 divides 12, 12 divides 24 means 1 divides 24, covered, right? 2 divides 12, this pair 2 divides 6, 6 divides 12, 12 divides 24, so 2 divides 24, that will come in chain. Then 2 comma 24, similarly. Then 3 comma 12, see 3, 6, 12, 24, that will also come in transitivity. Similarly 3 comma 24 and 6 comma 24 as well. So this is your Hasse diagram for this relation. So in Hasse diagram, suppose you have one more pair like 3 comma 9, right? 3 comma 9. How we can represent this 3 comma 9 in this Hasse diagram, right? Now 3 divides 9, we know, but 9 does not divides 12, neither it divides to 24. So where to take this 9? That may be the question will come in your mind, right? So you can take 9 somewhere here, right? And you can show 3 divides 9, and 1 divides 9, that automatically will come in transitivity. So one element comes like in hanging position like this, that is fine in the Hasse diagram. Okay, now next concept which is related to this Hasse diagram is chain and anti-chain. Chain and anti-chain. So let us define what do we mean by this. So first of all, we'll define the chain. So let a comma less than equal to, this is the symbol to represent the poset, right? Be a poset, a subset of A is called chain if every pair of elements every pair of elements in the subset is related. And let us immediately define anti-chain as well. We'll understand it by an example. So anti-chain, a subset of subset of A is called antichain if no two distinct elements no two distinct elements in the subset are related. Okay, now let us take one poset. Suppose a poset is represented in Hasse diagram like this: A related to B, then B is related to C, B is also related to D, then C and D are related to E, and E is related to F. So your set A contains elements A, B, C, D, E, and F. Okay, now how will you define chain, different chains, and the antichains? Okay, now according to the chain definition, if you have the poset and subset of set A, means subset of this set A we can call as a chain if every pair of element in that subset is related. So whatever subset will write, so every pair of element in that subset should be related. It should be shown some relativity, right? That is already been already get shown in the Hasse diagram. Okay, how we can write the chain based on this Hasse diagram, right? So to draw the chain, first of all you need to show that relation is poset or partial order relation, and you need to show that relation in the Hasse diagram, and then you can write the different chains, right? So I can write the chain like A, C, E, F. According to the definition of chain, it is a subset of set A. So A, C, E, F, it is a subset of set A, right? And every pair of element in the subset, should be related. Means if I consider A comma E, A should be related to E. If I consider C, F, then C should be related to F, right? So however, how I have written this A, C, E, F? If you see, look at the Hasse diagram, these all elements come in one chain, like A, C, E, F, right? I have not considered B. That is fine. Okay, that is fine. Or you can also write the subset like A, B, then C, E, comma F, right? You can also write chain as A, comma B, because A is related to B, and A, comma B is subset of this set A, right? You can also write the chain as A, B, D, E, F. You can also write the chain as D, comma E, comma F. So many different such a chains are possible. Okay, now let us go for the antichain. What antichain definition says? Subset of A is called as antichain if no two distinct elements in the subset are related. It's opposite to chain. So whatever subset you will write of set A, right? So from that subset, no two distinct element should be related to each other, right? So can I take C comma D? Yes, because if you look at the Hasse diagram, C is not related to D. C is not related to D, right? So I can take chain as C comma D. So from this Hasse diagram or Hasse diagram, right? This is only one antichain possible. right? But it may possible that more than one antigen also you can get.